Hi guys, this is the video for chapter 9, lesson 1. So in this lesson, we're taking a look at reflections. So when you think about a reflection, if I put a mirror in front of us, right, you'd think that we would have a mirrored image, what you see here, facing just flipped and looking at the other side on your mirror, right? And so when we think of reflections on a coordinate plane, it's really just a flip reflection of an image. And so the important thing for us to know is when an image is being flipped, we have to have it be flipped over a line of reflection. So that line of reflection is kind of like the mirror. So the first thing we're going to do is just talk about how we can create a mirrored image. And so a mirrored image, when we're just drawing it as a picture on a piece of paper, the thing you need is your image first. So let's say I have an image here, it's a heart, and then a line of reflection. So that's kind of your mirror that is where the reflection is happening, right? And so how we figure out how to draw a reflection is basically every point is the same distance from that mirror. So and it's a the to calculate distance, we can calculate it by basically drawing a perpendicular line from that point to the mirror or the line of reflection. So I mean, this is a round object, my heart's round, so it's hard for me to have exact points, right? But if I think about this, let's say that this line here was about 2 inches, then I would think about my image has to be 2 inches to the opposite direction, making a right angle, right? And then same thing, right? So you're going to have your image, same distance, and it's going to be reflected across, and there's your image, right? My image isn't going to be perfect because my drawing, I'm not really doing all the right calculations here, but maybe from here to here, it would have to be the same distance. So when I measure all these lines out from point to the line of reflection, it's the same distance. So if we were to do our own, my recommendation for you is definitely get a ruler out and measure out, draw a straight line, a perpendicular line from each point to the line of reflection. So J to the line of reflection is about this distance. You're going to kind of lightly draw a line the opposite direction, but the same distance. K is right on the line of reflection, so I don't have to change anything. And then another perpendicular line going the other way. So I think it's going to be kind of like that, right? About that same distance. And then now I can connect my points. So here's my point. When I connect them, this is my mirrored image. And so I might want to like take off these lines of reflection so that if I can, I don't know if I can not select that, but let's see. Yeah, I think that whole thing is all together. So if I wanted to take off, these lines right here, I would see my image being reflected across. So same idea with number 2. If I'm reflecting this across, looking at the distance P to the line of reflection, well, I'm going to keep going. P would be right here. And then this is right on it. So L is right there. This is right on it. It's right there. Now M is over here. I'm going to reflect it across, probably there somewhere. And then N is like right there, maybe. So when I draw my image, that is my reflected image, and my drawing might not be perfect, but something like that, right? So that's my reflected image, and you want to measure it out with a ruler. Okay, so this one's actually reflected for you already, kind of, I think, because E goes to here where B is, D goes to where C is, A goes to where A is. So I think this one's already reflected for you. Can't do much, but you can definitely do 3, 4, and 6. It really is just more visual. Think of it as like kind of an art class with some drawing done. and you're just figuring out where like this is the line of reflection. Basically, how would you draw the reflected image, right? Even if I don't measure it out, I know visually the reflected image is going to have to go like this, right? It's going to have to go something like this, right? So you're just roughly getting that image drawn. It's going to have to go something like this, right? So that's your image drawn. Okay. Now when it comes to coordinate planes, when you're drawing a line of reflection, same idea applies. You have to, or when you're drawing a line of reflection, when you're drawing a reflected image, same idea applies. You have to have a line of reflection because that's your mirror, right? Without a mirror, there's no reflection. So the big thing that we see here is you are going to be given the line of reflection, okay? And so let's take a few notes and just talk about this. If you have a reflection, and this is what your other video, that wasn't me, was over. When you have a reflection on a coordinate plane, there are so many different lines of reflections you could have. You could have a line, I'll use yellow, that's reflecting horizontally, right? So your image would go top reflected over to the bottom on the other side. Your reflection could be on the y-axis or vertically. Could be a vertical line of reflection, and so your reflection could go left to right. Your reflection could be not horizontal, diagonal, right? Could be diagonal across like this, or diagonally across like this, right? So, if I had an image that was across this line of reflection, if I had a heart here like this, it would be reflected across this line, this diagonal line, across to the other side. So it's reflecting, from my positive XY coordinate to the negative, both negative XY coordinate, right? And so if you can remember a few kind of rules when it comes to reflections, it will help you greatly when you're doing these on a graph. And so I would recommend writing these down, and you'll probably be able to use these notes on your test because I don't expect you to remember these, like to memorize them, but knowing them will help you a lot. So let's talk about reflections. When we have reflections, there are 4 types of reflections, right? Just like what I talked about here with all these colors. The yellow one would be the reflection over the x-axis. So reflections over over the x-axis. And so if you had a point that was at xy, the reflection would end up being at x negative y. So let's take a look. If I had, let me erase this here. If I had a reflection, I'll use red maybe, where I had a point at 1, 2, 3, 1, 2. So 2, 3, this is at 2, 3. If I'm reflecting it over the x-axis, that means it's gonna show up down here. My x is not changing, but my y becomes negative. So the position where the x is does not change, it's still 2, but this becomes negative 3. Does that make sense? So when you have a point that's at, an xy point, your reflection is going to have the same xy, except for your y is going to become negative. Now let's talk about over the y-axis. Now, why don't you guys think about, maybe draw it out, predict what you think the reflection would be if I had an xy point, okay? So if I had an xy point, think about this red dot. If I was reflecting over the y-axis, so reflecting over this pink line vertically, it looks like my y won't change, but my x becomes negative, right? This becomes negative 2, 3. So our conclusion is that this will become negative x, y. And so when in doubt, just draw it out, see if that works for you. Okay, now for the diagonal lines, okay? I feel like these are kind of the tricky parts. Reflection in the line where y equals x. So when you see y equals x, let's draw a little picture. That means the diagonal line is going like this, okay? This is a y equals x line. And so that is where, if you had x and y, the reflection would become simply flipped, y, x, okay? So let's say I have a point at 0, 0 to 5, I don't know, 0, 5. So that would be right here. And if it's flipped, so if this was 0, 5, it would flip and it would become 5, 0. So that means I would have a point at 1, 2, 3, 4, 5, 0. So think about this. It's flipped across this line from here to here, okay? Hopefully that makes sense. And now our next vertical line, not vertical line, our next diagonal line, what do you think it's gonna be? It's gonna be a reflection in the line, just flip-flopped, x equals y. And that's going to be a picture where your diagonal line is like this, and the reflection basically goes, if you have an xy point, then the reflection is going to be the flipped version, but negative. Negative y, negative x. So let's test it out. So if I have a point at, I don't know, 0, 3, 1, 2, 3, 0, 3. So 0, 3. I'm flipping over, then I'd have a negative 3, 0. 0 can't be, can't change it to be negative or positive, right? It's just 0. So that means I would have 1, 2, 3, no, let's see. Oh, I drew the point wrong. Oops. So here's my point. Let me erase this here. Gave it the wrong coordinate. So this would be 3, 0. And then if I flipped it, it would be 0, negative 3, okay? I would flip the numbers and make them both negative. So that means if I had a 0 or 3, 0, that's the point right here, my flip would be 0 on the x, and then it would become negative 3 on the y. So I go negative 3 on the y. There's my point. So see how from this line of reflection, they are just reflecting directly across from each other. All right, so these notes are going to be greatly helpful, and I think drawing this picture with your y equals x reflection and drawing this picture with your x equals y reflection will help you remember what diagonal lines are, because sometimes it's hard to remember what type of reflection that's talking about. So let's do a few on our study guide. On our study guide, they not only give us the image that we're reflecting, but they also give us the line of reflection. So in number 1 here, where it says x equals negative 1, that is the line of reflection. So I'm going to use maybe a red line to show that. So what I would do is I would draw a line that goes through negative 1 on the x, which means this is my line of reflection. And I'm going to reflect my image. So the nice thing here is you can really just count the reflection out. You don't have to do any math really. I mean, you could definitely say I've got G, which is at negative 1, 4. And then I have F at 1, 2, 3, negative 3, 1, 2, 3, 4, 5. And then you have H at negative 2, negative 2. However, because the line of reflection isn't like on the y-axis, you can't just follow the rules that we had talked about where the reflection, the notes that we took, where the reflections would just be like flip-flopped, or one would be negative, whatever. So we can just draw it out here. My reflection F would go right here, and then this would be 1 over, right? 1 over from the line of reflection on the other side. So now I can connect my dots, and that is my image. And that's all really I'm looking for here. And so you could, you could now say, okay, my line of reflection, given that that's -1, we also show an image that's been reflected or gone through a change by, rewrite that there, by putting a little apostrophe on the side to show that it's gone through one change. If there's 2 changes, we would put 2 little apostrophes there. So this shows that it's gone through a change, and then we could say this is still at -1, 4. This would be at 1, +5, and this would be at 0, -2. Okay. All right. So now I'm going to use a different color to show the line of reflection where y equals 1. So y equals 1, meaning this is my line of reflection. So I'm going to draw my line of reflection, and then I'm just going to mirror every individual point, because when I mirror every individual point and then connect those points, I will have a perfect reflection. So H is right here. It's 1, 2, 3 away from the line of reflection. So when I draw it on the other side, I count 1, 2, 3. That's going to be where H is. And then G is 1, 2, 3 away from the blue line, the line of reflection. So I'm going to count down 1, 2, 3. That's at G. And then F is 1, 2, 3, 4. Going the other way, 1, 2, 3, 4. So now I'm going to connect my points. Oh, connect them. It's hard to draw with a pen. Let me back that up a little bit. So Y to that, or H to G. And then there's my image. So I know it looks a little bit messy because there's so many images on here, but see how that's a perfect reflection over this original image. So honestly, you don't need to write all this stuff out here because it just says graph. It doesn't say write down the points. So I'm okay with you just graphing it. Okay, next part. Oh, perfect. Y equals 0 means a line of reflection is just on the y-axis. So let's remember, when you reflect over the y-axis, we can use our notes A, B, C, D, and I'm just gonna show you how this works. So I'm gonna write down all the points for A, B, C, D as they are originally. A is at 1, 2, 3, -3, 1. B is at 1, 2, 3, 1, 2, 3, 3, 3. C is at 1, 2, -1, 2, -1. And D is at 1, 2, 1, 2, right? -2, -2. Okay, our notes say that when I'm doing a reflection over the y-axis, all I have to do is make the x negative. So I'm going to write down that my points are going through a change, A, B, C, D. That's the change. And then I'm going to make my x-axis the opposite of what it is. So if it's negative, then I'm changing it to positive. If it's positive, it becomes negative. This becomes -2, -1, and this becomes +2, -2. So when I plot my points, hopefully I will have the right image. So the y-axis is right here, that's at 0. So B is going to become right here. A is going to become, ooh, back up a little bit. One, two, three. Here. C is right here. And D is right here. Okay, so when I draw it out, there it is. That's my image. Okay, and I can double check, like I have three, three positive one, 1, 2, 3, positive one, there's A, right? So that works. B is at -3, +3. That's B. Oop, B tally. Okay. Does that make sense? I'm not gonna do the rest. Okay, I'm gonna do the other one in red so that we can see it better because it does get messy. So x equals 1, meaning my line of reflection is right here. So when I reflect all the points, I'm reflecting them across this line. A is on it, so that's just gonna stay there. D is gonna go the opposite direction. B is 2 away from the line of reflection the opposite way. C is 1, 2 away. So I'm gonna draw my points, and that is, when I connect my points, I will see the reflected image over the x-axis. I know it looks kind of messy, but think of your green, I mean, not your green, your red image reflected in comparison to your black image. Okay, so these last two, it tells you to graph the image and then reflect it in the x-axis and in the y-axis. So we already talked about these in your notes, and so you can just use your notes to kind of find the reflected image. And so if I know my original points are those, I could say D, E, F, and either draw them both out, draw the first image first and then reflect it and then come up with the points, or come up with the points right away, because you know reflecting over the x-axis means the y becomes negative. So this would become -2, 1, where because this is negative already, it becomes the opposite. This would become -1, -3, and this would become 3, -1. No, +1, 3, +1. Okay. So then let's draw it. -2, -1, there's D, -1, 3, there's E, 3, -1, there's F. So connect your dots, draw it out. Now reflecting, maybe I'll use a different color. D is at -2, 1, -1, -3, and then 3, 1. So see how that's just reflected directly across the x-axis. Looks good. Okay, number 6. So when you reflect your images over the y-axis, the B or the x position becomes the opposite. So you can pause and work this out. These would be your reflected points. Okay, so A, 1, 4, 3, 2, 2, -2, -3, 1. Reflected over your y-axis. So it's just going directly vertically across. So this becomes -1, 4, -3, 2, -2, 2, -2, -2, and then 3, 1. Draw your reflection. See how that's reflected? All right, looks like a good sign. Okay, that's all I have for you for 9-1. Hopefully that made sense, and we can talk about anything in person if you have questions.